All right, we're not finished yet with the topic of artificial intelligence. We're going to jump right into two quick, crisp, and informative keynotes. First off, I'd like to welcome on stage, here to tell us how to secure active learning for medical and space applications. Sorry. Let's welcome Benoit Mac. Benoit, well done. Welcome to the stage.
Hello.
He is a civil and electrical engineer and full professor at the Université Catholique de Louvain. I hope I pronounced that correctly. And since 2009, he's been a member of the Technology and Society class of the Royal Academy of Belgium. And renowned as a Dr. House of Pixels, his work advances image doing, security, and applications in multimedia, medicine, digital cinema, and television. Alongside his academic roles, Benoit actively contributes to the digital plans of the Walloon region, guiding its industrial redeployment.
Thank you very much.
Welcome. Great to have you here with us. And also for our second keynote, I'd like to welcome, or better yet, the first keynote, he's going to start it off, Pierre, Philippe, Mathieu. Welcome, Mr. Mathieu. And he's really passionate about uniting deep tech, space, data, and vibrant communities to tackle global environmental challenges, including climate change. And in his current role at ESA, he focuses on integrating Earth observation data, secure connectivity, IoT, and transformative technologies like artificial intelligence to swiftly provide actionable insights for users and citizens, fostering a more secure and resilient society. Pierre, Philippe, you may take the stage.
Thank you very much, Mr. Chairman. So good morning, everybody. It's really a pleasure to be with you, so thank you very much for the invitation. To share my passion about space and also AI. And because the topic is big, I will focus really on these aspects of rapid response in the framework of what is called R3, which is an accelerator of ESA, and the program underpinning this, which is called Civil Security from Space. But let's not forget AI is just a tool, so our real focus is this beautiful planet, and that image has created the consciousness about us being on a spaceship. And as you know, we are the crew of this spaceship, but we need a captain, a pilot, and we also need a co-pilot. So I think AI would be the perfect co-pilot because of the scalability and the automation, and we will see this. But you can see also that it's a loop. That is iterative, and that human is at the heart of this. And this loop could also change the observation we need in order to optimize the decision. So we have talked about the Big Bang. I mean, James mentioned the Big Bang of deep learning. The word intelligence is difficult to define, so what fascinates me about this technology is really the ability to create software automatically. You have a problem, you don't fully understand it, you get the data of these problems, the machine learns and creates you a software, which are the parameters here. And you see this creates a totally new value chain for Earth observation based on data augmentation on the left side, which is really the key, open software in the middle, and then this variety of application in computer vision. But AI is really dynamic, so there are revolutions every few, 6 months or something. So here you see the revolution about weather forecasting with new technology like GraphCast from DeepMind, but also from NVIDIA, the neural Fourier transform. These technology, they leverage open data from Europe based on the model of weather forecasts that have been running for decades with physics. They capture that and they create accurate forecast like for 10 days. So something big is happening. In fact, it's a disruption. And this push weather forecast to think about it, integrate this as a kind of hybrid system. But we'll talk about that later in May at ESRIN. With ECMWF, there is this workshop, so take note of this. And the next revolution is generative AI, and that's really recent. That's from last year. And this is a picture I asked ChatGPT to do to illustrate, in fact, what would be a control room for the planet with satellite technology. And it came up with this in less than a second. And this technology of Gen AI led to the large language model, like the ChatGPT revolution. And you could argue that it's a kind of holy grail for us. It's a new tool to interact with data because natural language is the most natural thing to do. So we are now able to interact with data in a new way. And this is a mock-up example of a copilot called Gaia. And you go to a place, and then you ask, where is the vegetation? And it would go and leverage Sentinel data, calculate the indices for you. So this is a mock-up, but in fact, I posted on LinkedIn a link to an app that was created after the release of GPT-4 Turbo, where you have customized GPT of someone who put together Earth observation and GPT, and you can already do this today. You could also ask, what is the air quality? It would go and fetch the prediction for you, give you contextual information. You could ask if you are a scientist about climate. It would give you the parameter here, essential climate variables. But it could go further, and you could ask questions about interaction in this Earth system, because this is the nature of the Earth system. Ocean, atmosphere, and land interact. And AI is very good at extracting patterns that the human eye cannot see. So here you would cubify your data, and it would understand interactions. You could ask, what's the impact of El Nino, for example? And it would go on the land, carbon cycle, economy, and gives you all this information. Also, if you are in the business of disaster management, which is the topic of this talk, you could ask, oh, what's happening after the extreme rain in Nairobi? And it would give you a map with the flood that it would calculate real time, but also the vulnerability, understanding how the human is affected by this. So it's a whole new layer of information. And this is just an example of FDL run by James about creating a flood report, a kind of situational awareness after a flood of what's happening, picking up different data of the web, so that you have a holistic view of the disaster. And the new paradigm in AI is, in fact, building huge model like GPT, large language model, but it's also enabling us to split a big problem into small chunks. And this is federated learning, and the next speaker will talk about this for another field, which is a medical field. But what we notice in the development of machine learning for space is that you would train different type of AI for different type of tasks, like land cover, segmentation, physics inform, etc. And this is already very powerful in itself. But today, it seems that there is an additional advantage at training a huge model of many tasks, so meta-learning, and then tailor this big model for some specific task. And this is the paradigm of foundation model, where large language is just one aspect of it for language, but there is no intersection between language and computer vision. So you could do a variety of things with these models, like classifying clouds. And you see here the interaction with humans. So each time you have a result, AI is not good at the edge cases. For example, when there is a shadow or when there is snow, and you would confuse it with cloud. So the human would spot that and would create an annotation, and the AI will learn. So it keeps learning and improving. So the accuracy can increase and is beating, in fact, the traditional techniques. Another amazing aspect for me is the machine sees the data in a totally different way, in the space of what they call embedding. So you can fuse optical and radar together, but really in a different way that we did before, where we took a product from the optical, a product from the AI, and we put the two products together. Here you would think of transforming a radar into an optical data. So you would finally understand radar data by looking at it with an optical filter and put these together. Of course, there are the big issue of hallucination, error characterization that were mentioned before. So this is an ongoing field. And you can fill in spaces into this like clouds. Or enhance the resolution of your satellite, for example, because it has understood the representation. But the next frontier is to put AI in space, and in particular having orbiting computers. Okay, so this is an example of what the model could look like. And by doing this, you would have a kind of iPhone moment for satellite, where you would have different apps working at different places of the orbit. So you could have a sea ice app in the polar regions, tropical forest, etc. So it's totally different and dynamic way to have a kind of software-defined satellite as opposed to one mission with one purpose. And this paradigm is being tested right now. So we started with VSAT, which demonstrated the ability to put an off-the-shelf chip on a satellite, and it works. So the issue was radiation, so it works. So it means you can deploy machine learning in space with technology off the shelf. This is a revolution in itself. It opens a wide avenue. Then we demonstrated on the orbit that you can actually reprogram this, so run the software and reprogram. So you open the gate for reprogrammable satellites that could act intelligently as a tip and cue, for example, model where Spire would spot a ship, tell the Ion platform something is going on. It would program ISI to look better at this. The AI would then understand if there is an anomaly and predict the trajectory of the ship that would tell the platform to look with optical. So you can see that there is an opening of fast loop enabled by the AI and totally flexible and agile. You could do the same for methane, for example, having a medium res spotting problem and then a high res giving you more detail. So even by combining different satellites, you could spot methane, then ask new space missions to zoom in. This is an example again from FDL where for space weather and the next mission coming up called Vigil at Lagrange point 5, you have only one angle. So by doing a kind of 3D version of the sun with AI, you could reconstruct this with two observations. So you see here the interaction with edge computing where you have pieces of information of the puzzle and large model on Earth where you put these together, which is exactly the nature of federated learning. And I'll stop with this slide, which is the vision of the civil security from space, where you see all these space assets, which today tends to act individually, like one mission is downloading. So the vision there is with the emergence of new telco link, and in particular, optical link between satellite and AI on board, there would be a kind of connection between these things that would act as a kind of nervous system that we mentioned before and would accelerate the timing to information. You would download the information directly on your cell from this connected system. And I stop that here with that vision. Thank you very much.